in industry. So these are some of the enablers that are causing bin picking to become easier. But at the end of the day, everything must work, and I'll cover these issues as we go forward here. So let me outline some good applications by certain vertical markets that already have been proven and are quite feasible to do. Engine blocks, as I mentioned, cylinder heads, axle shafts, in powertrain, differential carriers, pinions, round parts with stems, connector rods, which is the big picture on the left, piston heads, so the picture on the bottom right, brake rotors, and stacks of gears. These are parts that are typically found in powertrain applications, engine type related applications, and a lot of the key components that make up these powertrain products are bin pickable. So that's a very encouraging sign. Next, let's take a look at automotive stamping. These are situations where flat metal is bent with heavy presses to form the shape of a door or a roof or a hood. And typically when these parts are stamped, we also get holes that are typically used to weld or to join with other smaller parts. Progressive stacked stampings are typically smaller parts that attach or are welded to a bigger part like a door, and usually they're supplied in bins with some skew to them just to facilitate a lot of parts in the same bin. Those have also become very feasible. And we are also seeing final assembly products in boxes in what are called trim chassis final environments or final assembly, which can be picked out of a bin and put into moving lines, moving conveyors. Okay, and then let's take a look at a non-automotive example of packaging, food packaging. Strips of medical tablets, flat but randomly arranged in boxes. Sometimes these, as you can see in the picture on the top left, these strips of medicine sometimes have one side that has no features and another side that does have features or markings on it. Those are all feasible to do now. A second area, which is the one on the right up at the top, is bags of products such as chips or salsa or cheese. A lot of times these bags are used in intra-packaging operations where there are no markings. And what's remarkable about these solutions is that these parts actually can change in shape also. It's one thing to find objects in different positions like X, Y, Z or yaw, pitch, roll. It's another to then also have shape variation, but there are techniques to deal with that are becoming more and more feasible. A third example of packaging is tubes or upright layers of copper, plastic, or PVC pipes. They typically don't have holes or features on them, but just by virtue of the fact that they are lines in space or their cross sections are circles in space that are skewed, allows vision algorithms to make bin picking possible. And finally, at the bottom right, we see layers of products such as wooden planks, plastic sheets. These are also becoming feasible, and please note that they don't have features on them, we just have layers. So these different types of products and geometries are becoming feasible for bin picking. All right, so let's go through a procedure of how to do bin picking. Let's say if you have a manufacturing operation and would like to consider bin picking, and would like to reduce the labor cost and improve your throughput and flexibility while still utilizing your old bins without modifying them, what would you need to do to see if you could do bin picking? So let's go through that procedure and see what it takes to do that. The instructions below are a bit precise, but they're not difficult to follow. And it involves, first of all, taking pictures of your parts. So you'll need 2 cameras to do this. And they don't have to be industrial cameras. You can use typical consumer cameras or cell phone cameras. The first thing to look for every part that you manufacture is its resting positions. So consider each part that you may manufacture. You may have many, and then for each one of those parts, consider the multiple stable resting positions which can occur if you were to put it on a flat surface, and document that. So for example, a Coca-Cola can typically has two resting positions. One when it's standing up on its circular footprint on a flat surface, and the second when it's lying down on its side. Those are two resting positions, stable resting positions of a Coca-Cola can. Now in a bin, of course, each one of those resting positions will be skewed in X, Y, Z or yaw pitch roll, but the idea here is to identify stable resting positions and to think about grasping strategies for each one of those resting positions. Here's another example of a piston head, which may take 4 different ones. So the thing to do is to take pictures of each stable resting position and aim your camera at about 45 degrees to the angle to the flat surface so that we can see some of the perspective and collect this in a set of part pictures. The second thing, so we've just looked at individual parts and their stable resting position. The second thing to worry about is how random can these parts be. Sometimes they're not so random, they're just more or less just skewed in a box. On the other hand, as you can see in this picture here, these piston heads are quite random. So it's important to understand how random these parts are. And so the thing to do is to review how randomly your parts are in your manufacturing operation. Use a tripod or a temporary structure, set up 2 fixed mount cameras, and then take the following pictures. Call one camera C1, and depending on the size of the bin, adjust the size of the view, which is also called the field of view, so that your image is indeed the entire bin. Once you have that, place the first camera directly above the bin and look straight down on a perpendicular fashion as it's shown in C1, and take a picture of that and document that as the perpendicular image or the C1 image. Next, use a second camera at an angle and point that at say roughly a 45-degree angle and take the same scene's picture and also collect that image. So when looking at a bin like this with 2 different cameras, the planar 2D views of the 2 cameras will be skewed, and that's okay. The important thing is to document these in a file structure so that for every part style you have the individual part pictures, stable resting positions, and also 2 sets of pictures for each part on how randomly they occur in bins. This is some basic homework that's needed to assess if bin picking is possible or not. So for each of your parts, place a bin, collect these images, and organize these things. Okay. The next thing to do is to look for bin picking experts. There's a growing community of bin picking experts out there, and so you can Google search them, and they form your potential pool of vendors that can supply you with bin picking solutions. It's important to make sure that they have some past work that they can show, because there's quite a bit of hype out there, and it's important to make sure that people that are touting that they can do bin picking indeed have a track record. A good place to find such people is also at trade shows, conferences, webcasts, and open houses. Okay, so the first thing to do is to supply this data that you just collected. Find all your parts, all these pictures. You may need to assess what are your high volume parts. Perhaps you don't want to do all of them in one shot. Maybe you may want to pick your top 6 runners that form the bulk of your manufacturing or the bulk of your cost of manufacturing. And then go ahead and approach these folks and ask for an evaluation of your parts from the pictorial information you've collected, and obtain a budgetary estimate to see what the cost will be to do this. And then if the payback or investment is justifiable, then proceed with additional steps. So let's say if the financial aspect is justifiable, then the first thing to really do, and this is a critical part of bin picking feasibility, is insist and expect to get a demonstration of bin picking with your parts. Now, you may need to pay for these in a 2-week or a 4-week or a 3-week engineering exercise, but it's very important to not rely on similar parts or something similar, because geometric differences can create a big difference in feasibility or not. Case in point is I personally was involved with some connector rods, and not all connector rods are made equal. One type was very feasible and the other one took a lot of effort to do. Ultimately they were both successful, but it's very important to insist on having the confidence to see a demonstration with your parts. And like I said, you may need to pay for it, but the deliverable out of that is that you can actually really see for sure that it will work for you. Okay, now in bin picking, there are several roles in the actual implementation. Sometimes these roles are fused into one or two companies, but if you just look at the roles themselves, there are several roles. There is the role of the end user, the company that's actually purchasing a solution or is hoping to receive a reliable solution. And there's the supplier, which is typically a systems integrator. It's very important to have a single line of responsibility with one vendor who may have all these roles in their own organization, or who may need to subcontract some of this work. And so the key pieces are a robot, a machine vision system, and most importantly for bin picking, software. Some integrators can do the robot and vision piece without a problem, but may need to rely on a subcontractor to provide the software for bin picking. This is not uncommon, but at the end of the day you want a single line of responsibility that's delivering to you. Now there's several very good companies out there, as I've mentioned on the left: Fanuc, Sony, Stoibli, National Instruments, KUKA, Motoman. These are all very well established players out there. And again, the key thing is to make sure that the roles of the end user, the integrator, robot vision company, and software company are all covered and everybody's comfortable. One thing that these demonstrations do is that they bring about a lot of cooperation, because everybody's interested in a sale, and it is very important to see how the demonstration works out. If it works out, then it's also a little bit of a blueprint for the actual integration in terms of where the cameras will go, what types of cameras there will be, and some of the tooling aspects. And collectively it creates a sense of confidence on how to approach a particular problem. It also protects the success for all parties, in that not as much as the end user is interested in their success, the suppliers also have their reputations tied into a project, and it's important for them to feel comfortable that they can deliver on the specific project and specific geometry and specific level of randomness in the parts. So I also encourage you to go and visit factories where bin picking is taking place. There are several factories out there now that are using bin picking. Some may not allow visitors for confidentiality reasons. Others are quite happy to show their successes. And it's useful to go and talk to these folks and see how they implemented things, and to get their perspectives in terms of support and training, logistics, and how they time the project around critical production commitments. A second key to success